Hello everyone, welcome back to my channel. In today's video, we'll learn how to calculate the Reynolds number, one of the most important parameters in fluid mechanics. We'll understand what it means, how to classify flow as laminar or turbulent, and then we'll solve a real problem. The Reynolds number is a dimensionless ratio that compares inertial force to the viscous force in a fluid. The formula is simple: Re equals rho times V times d by mu, where rho is fluid density, v is average velocity, and d is pipe diameter, and mu is dynamic. The Reynolds number also help us to predict the flow regime. If Reynolds number is less than 2100, the flow is laminar, that is smooth and orderly flow. If Reynolds number is in between 2100 to 4000, that is transition flow. Above 4000, it is turbulent, where eddies and fluctuation dominate. Let's consider an example. Water at 25 degrees Celsius flows through a circular pipe with a diameter 5 centimeter and average velocity of 0.6 meter per second. So given water density 997 kg per meter cube at 25 degrees Celsius and viscosity 0.3089 Pascal second, and velocity is already given, that is 0.6 meter per second, and diameter is 5 centimeter, so we can convert this 5 centimeter to meter, that is 0.05 meter. So now we can calculate Reynolds number. So Reynolds number is rho v d by mu. So we can plug that. Rho is 997, v is 0.6, d is 0.05, and mu is 0.0089. So ultimately, after putting all this value, and if I do the calculation, so it will be 33,606.7. Obviously it is greater than 4000, so it is a turbulent flow. Now here I am taking same velocity and diameter. Now if I change the different fluid like water, air and light, oil, so here that fluid properties are different. So first, water density is 997 and viscosity 0.0089 Pascal second. So again if I plug, we'll get the Reynolds number 30.60617. So it is a turbulent flow regime. Now if I take air properties is different than water. So rho is here 1.184 kg per meter cube, mu is 0.402, and if I calculate Reynolds number, so that will be 1920 less than 2100. So flow regime is laminar. And light oil, so rho is 870 kg per meter cube and mu is 0.00890 Pascal second. So Re here 2932.6. So flow regime is transitional. Now here we can calculate the Reynolds number with a interactive mode. So first, if I choose air, water, so now here you can see, okay. So now here if I take water, so here I am taking velocity is 0.6, so and diameter is 0.05 meter, so Reynolds number is 30.606.7, and flow regime is turbulent. Now we can change here water to something air. So again, so Reynolds number is 1920 and flow regime is laminar. We can change light oil also. Now here we can change the velocity. If I change velocity, so you can see that Reynolds number will change, and along with the flow regime also change. So you can do like that. That the slider you can change the velocity, and based on that you can get the different flow regime. That's it. We have learned how to compute Reynolds number and we interpret the flow regime. If you found this video is helpful, give it a thumbs up and subscribe for more videos on chemical engineering concept. Thanks for watching, and I'll see you in the next video.